Greeting for yours, my name is Andina Octavia and today I would like to presenting about temperature and heat. So the main references this chapter is this book and from the other website I found on the internet. Next, we will discuss about temperature, heat, internal energy, calories, and specific heat. First point is heat and temperature. Heat and temperature are interconnected terms but not mean the same thing. Heat refers to the amount of energy in an object, measure the total kinetic and potential energy contained by the molecules in that object. Temperature refers to the intensity of heat, measure the average kinetic energy of molecules in a substance. So, heat is form of energy and the temperature is a measure of that energy. Every human being can feel the hot and cold of an object because of temperature. The Encyclopedia Britannica also defined the temperature is a measure of hot or cold expressed on an arbitrary scale, where the scale shows that hot temperatures that have high energy will flow to cold or lower temperatures. That's why temperature can be expressed as a qualitative measure of an object in terms of degrees. That's why temperature can be expressed as a qualitative measure of an object in terms of degrees. This temperature can be measured because of the kinetic energy in an object. So, the greater kinetic energy of an object, the higher its temperature will be. Why? Because the molecules is moving faster and rubbing together until the term is higher. Next, the temperature is organized into three types of temperature scale in general, namely a Fahrenheit, Celsius, and Kelvin. The temperature scale will be based on 2 points. It is the lower fixed point or freezing point and the upper fixed point or boiling point. By these 2 points, in each type of temperature scale are expressed as the first one is Fahrenheit. Fahrenheit temperature scale or the freezing point of pure water is set at 32 degrees Fahrenheit and the boiling point of water is 212 degrees Fahrenheit. And then the Celsius is set by 2 fixed point at 0 degrees Celsius from the freezing point of water and 100 degrees Celsius for the boiling point. And the last one is Kelvin. The freezing point of Kelvin scale is 273.15 kelvins and 373.15 kelvins. By the way, there is no degree symbol used for Kelvin scale, it's only read blah 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 kelvins. For example, 15 kelvins, 118 kelvins, and etc. If you want to know the temperature of each scale, use the next table to convert them. There is Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Celsius, Fahrenheit to Kelvin, and also Kelvin to Fahrenheit. You just use this formula to calculate. For example, convert the 98.6 degrees Fahrenheit to Celsius. First, we will convert to Fahrenheit terms to Celsius terms with this formula and calculate it until find the result. 98.6 is subtracted by 32 is 66.6 and then 66.6 multiplied by 5 is 3033 and divided by 6 equal 37 degrees Celsius. To make it easier, I've included a temperature conversions like this. As we can see, the comfortable temperature on 22 degrees for Celsius, 269 for Kelvin, and 72 for Fahrenheit. Next, we move to expansion related to temperature, especially the thermometer. Heat will flow from hot objects to cool objects because as the particles move, they will impart some of their kinetic energy onto other particles through collisions. This will continue to occur until the whole system is at the same temperature, in a state called thermal equilibrium. This is how thermometer measures the temperature. Heat from the environment will be in contact with the thermometer and flow into the thermometer fluid, causing the atoms to gain kinetic energy, and the column will expand until it is in internal equilibrium with the environment, thus allowing us to read the temperature in one of our man-made units. Next, the internal energy. The sum of all of these types of energy that are exhibited by the particle of a substance is called internal energy of that substance. The internal energy represented by an uppercase U. This is the energy associated with atomic motion, and it is a quantity that is directly proportional to the temperature of a sample. Higher temperatures mean more internal energy, and lower temperatures mean less internal energy. In this way, we must understand that a substance doesn't contain heat. It contains internal energy, like the kinetic energy of all the particles, and it is the transfer of this energy from areas to high temperature to low temperature that we call as a heat. The solid molecule is motioned by vibration, while the liquid molecules motioned by bouncing around from one place to another. The conclusion is temperature involvement only kinetic energy, while internal energy involves both kinetic energy and potential energy. A second important distinction between the two is that temperature measures the average kinetic energy of the molecules, and internal energy refers to the total energies of all the molecules of an object. Heat is the internal energy that is transferred from one object to another as a result of a difference in temperature between the two objects. Note that heat is not in an object, but is energy that is being transferred from one object to another. So next, we will discuss about calories. Although heat and temperature are different things but obviously related. Calories is the amount of heat. When we added heat to an object, its temperature rises. For example, if we added to 1 gram of water, raises the temperature of the water 1 Celsius degrees. And the last topic I've been presenting is about specific heat. Specific heat is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 Celsius degrees. The units of specific heat are usually calories. In this table, there is a specific heat of a substance. Since water requires 1 calorie per gram Celsius degrees, the specific heat of a substance is equal to the number of calories required to raise the temperature of 1 gram of the substance 1 Celsius degrees. The relation can be expressed by this formula, where H is a heat added or removed, M is the mass of the substance, C is its specific heat, and also delta T is the change in temperature. And the last one, I have an example. How much heat is required to raise the temperature of 150 grams of iron from 20 degrees Celsius to 25 degrees Celsius? The answer is 82.5 calories. And the solution is, we can use the formula. M is 150 grams multiplied by specific heat of iron, that is 0.11, and then multiplied by change of temperature, which is 25 mean 22 is 5, and then calculate it until we found the result is 82.5 calories. And that's all about my presenting. Thank you.